Hello ninth class. Today we are going to learn about certain properties of gases. We learned about behavior of a gas in our first video. Now today we will be learning some properties which are very important. First one is mass. Gas, as we all know, has a definite mass, and mass of a gas can be expressed in grams or moles. Now the number of moles of a gas is equal to mass of a gas in grams divided by the molecular mass of a gas. For example, somebody says ki I am having around 48 grams of nitrogen gas. So what is the number of moles of gas? So I will find out what is the molecular mass of nitrogen gas is how much. One nitrogen atom is having 17, so molecule is N2, so it is 28. So I will divide 48 by 28. Whatever is the answer will give me the number of moles of the gas. Second property which I will be studying is volume. The volume of a gas is always equal to the volume of container. Why? And because we know that the volume of a gas is not a definite property. Shape and volume are not definite, they keep on changing. If I take a small bottle and a gas is filled in it, a scent or a perfume bottle is there, it's a very small bottle and large amount of gas is stored with high pressure. If I release that pressure, gas will come out from it and will fill the room. So liquids as well as gases can occupy whatever space is given. So volume is generally the volume of the container in which it is being stored. So it is actually the space occupied by the gas. Then volume can be expressed in milliliters, cc, centimeter cube, or decimeter cube, or in liters. And the conversion is 1 milliliter is equal to 1 cubic centimeter, 1 liter is equal to 1 cubic decimeter, and that 1 liter is equal to 1000 cc is equal to 1000 milliliter. This conversion many a time is useful. Then third property which we will be taking into consideration when we will be studying about gas laws is the temperature. It is a measure of kinetic energy because molecules of gas are considered to be moving in all possible directions. That means they are having kinetic energy, and kinetic energy is associated with temperature. So temperature of a gas is generally been expressed in two scales. One we take a degree Celsius scale, or one is known as Kelvin scale. In temperature on Kelvin scale, generally conversion if you want to do, so you do whatever is the temperature given in degree Celsius, you add 273 to it. For example, you are having 10 degree temperature, so here the temperature in Kelvin, if I am converting, will equal to 283. 273 plus 10, it will become in Kelvin scale 273 Kelvin. Like here it is given 10 degree, 283 Kelvin, and if it is 100 degree, it will become 373 Kelvin. And if you want to convert reverse, then you subtract 273 from there. Rearrangement of the formula is required only. Then the fourth parameter which we are going to study is pressure of a gas. We all know that we learned in first YouTube video that gas molecules are elastic in nature. They keep on moving in all possible directions with great force. Now when they are colliding with one another, because of elastic nature, they don't stick. They are not only colliding with one another, they are also colliding with the wall. So the pressure of a gas is generally the collision of gas molecule with the wall of the container. The pressure of a gas is the force exerted by the gas per unit area on the wall of the vessel or the container. The pressure of a gas can be expressed in mm, millimeter of mercury, or centimeter of mercury, or it is expressed in atmosphere or in kilopascal. And the conversion unit is given 1 atm is equal to 760 mm of mercury, 76 centimeter of mercury, or 760 torr of mercury, or is equal to 101.32 kilopascals. So this is a conversion unit. Now after this all, we will be studying about the gas laws. There are certain conversions which you have to do in your book. My book is slightly different, but the content is same. So for here it is conversion. Question may come, convert 37 liters into centimeter cube. So 1 liter is equal to 1000 cc. 37 liter will be 37,000 cc. Converting 5 atmosphere pressure to kilopascal. So 1 atm is equal to 101.32. So 5 will be multiplied by 5, 506.625 kilopascals. Now here it is converting 87 Kelvin into Celsius. So Kelvin is 273 plus degree Celsius. So when we want Celsius, we will subtract Kelvin from 273. Now it will be there. So 87 minus 273, it will become minus 186 degree Celsius. So this is from another book. Your book is also having that conversions. Just for knowledge I was giving it. In next video we will be studying about gas laws.